Today Miss Colley explains factors and multiples. Don't worry, I will redo my video like I normally do, but it wasn't uploading, so this is the backup for now. Our learning intentions are to know what factors and multiples are, to understand that each number has infinitely many multiples, and to be able to find factors of a number. We also want to be able to find multiples of a number. We will know we are successful when we can list the factors of a number, and you can list the multiples of a number up to a certain limit. We use factors and multiples in everyday life all the time. An example is nurses who would use factors of 24. When they're giving out prescription medication in nurses or in old age homes, they might be told that they need to give out the medication 4 times a day. This would mean they would need to do it every 6 hours, because 4 times 6 is 24. Or the medication might be 3 times a day, which would be every 8 hours, because 3 times 8 is 24. In 600 BC, before Jesus was born, the Greeks built on the early work of the Egyptians and Babylonians and their knowledge of math. Thales of Miletus, who's known as the father of Greek mathematics, is credited at having us understand the number theory. One of his students, Pythagoras, who you might come to know in mathematics quite a lot, he went on to become one of the most known mathematicians to ever live. That's why we know him so much. And factors and multiples are key parts of the number theory. What you might not know is that Pythagoras was actually also a religious leader. But he believed that understanding the world could be enhanced through the understanding of numbers. Let's talk about factors and multiples. Let's imagine you have 12 donuts packed into rows of 3 rows of 4 donuts each. We would know that that is 3 times 4 because the rows are repeating with the same numbers. So we could say that 3 and 4 are factors of 12 because they multiply together to make 12. If we went to Krispy Kreme, because they're my favorite donuts, and we purchased multiple packs of 12 of donuts, I could end up with 24 donuts or 36 donuts, 48 or maybe even 60 if I was feeling very hungry. This would depend on how many packs I bought. Therefore, all those numbers, 24, 36, 48, 60, are known as multiples of 12, because if we had multiple 12s, that's how many we would get. So our key idea is that a factor of a particular number are the numbers that divide into the number. So let's do an example. Let's say I have the number 20. I've got to think, what are all the numbers that could go into 20? Well, I could go 1 times 20. I could go 2 times 10. 3 doesn't go into 20, so 3 is not a number. 4 times 5. And then the next number would be 5, but that's 5 times 4. So as soon as we hit a point where we reach the number on the other side, we can stop. We then need to write the numbers in order. 1, 2, 4, 5, 10, and 20. So these are all the factors of 20. We know that every number will have a factor of 1 and itself, because obviously 1 can go into every whole number, and itself can go into every whole number. Let's talk about multiples. The multiples of a particular number are numbers created by multiplying that number by another whole number. So let's do 20 again. If I times 20 by 1, I'd get 20. 20 by 2 would be 40. By 3, 60, 80, 100, 120, and so on. That's why it has infinity number of multiples. Other multiples of 20 could be 480, 2000, 600, etc. All right, let's talk about how we find factors. Let's do some together. We're going to find the factors for 15. A is 15. So I always start with 1. I think of 1 and I think, what's the other number? 1 times what? It's going to be 15. So I write my 15 at the end. Then I think 2. Does 2 go into 15? No, it does not. What about 3? 3 does. 15. 3 times what equals 15? That would be 5, so that goes at the end. What about 4? 4 does not go into 15, and then now I've reached 5 again. And once I've reached that number on the other side, I can stop because I know that there's no more numbers. So my numbers of 15 is 1, 3, 5, and 15. So 15 has 4 factors. What about the number 40? I've got 1 and 40, obviously. 2 goes into 40, and that's 2 times 20. 3 does not go into 40. What about 4? 4 does. 4 lots of 10. 5 does. 5 times 40 is 8. 6, no, because 6 times 6 is 36, and 6 times 7 is 42. So that means 6 and 7 do not go into 40. And then I've reached 8, which is on the other side, so I'm done. So these are all the numbers that go into 40. So we can see the larger the number gets, the more likely it is to have more factors. All right, you pause the video and try give these a go. Let's check your answers. A, 21. Well, I have 1 and 21, not 2. 3. 3 times what? That's 7. 4, no. 5, no. 6, no. 7. I'm back to the start. So there's just 4 numbers. B, 30. 1 and 30. 2 and 15. 3 and 10. 4 doesn't go in. Oh, 5 goes in. 5 and 6. So I'm back to the start. Those are all the numbers that are factors of 30. Listing multiples. Now this is the easy part. Let's look at this. Write down the first 6. So I've just got to count basically in 11s. 11, 22, 33, 44, 55, 66. That's the first 6. Done. B. Sometimes it gets a bit harder if they ask us to do big numbers. So I'm going to start with 35, and I'm going to think, what's 35 plus 35? You can do a little maths on the side. There's one. Oh, 70. All right, add another 35. That's 105. Another 35. If you can do this in their head, that's really great, and I absolutely love that, and I would recommend that. But if you can't, you can just do a little bit of maths on the side to figure out what your next numbers are. 175, and lastly, there we go. So our multiples are just counting up in those numbers. You give it a go. All right, let's check your answers. The first 6 multiples of 4. Hopefully you can count in 4s. So 4, 8, 12, 16, 20, 24. But what about B? I'm just going to count up. However you found the answer, that's all good. We've got 26, 52, 78, 104, 130, 158. Did you get it? Lastly, we're going to find factor pairs. Now this is when we want to find 2 specific factors. Here it says express 195 as a product of 2 factors, both of which are greater than 10. So it wants us to find 2 factors, but it won't let us use 1 and 195 because it wants both numbers to be bigger than 10 and 1 is not bigger than 10. So I would start at 10 and say, does 10 go into 195? No, it doesn't. Does 11? In this part, when you're getting to these really big numbers, it's okay if you use your calculator, but remember that you won't have a calculator for your exam, but we won't have numbers this big on your exam. Otherwise, you can just figure out 195 divided by 11, that comes out at like 17.7. That's not a whole number, so it can't be 11. 195 divided by 12, that's 16.25. Again, not a whole number, it's not going to be that one. 195 divided by 13, oh, that's 15. So that's going to be the answer. So I got 13 times 15 equals 195. And that is showing 2 factors that make a product of 195, and both of them are greater than 10. You have a go at trying to do that with 165. Hopefully you went along and thought of your numbers greater than 10, and when you got to the number 11, you figured out that 11 times 15 equals 165. That's our answer. Hopefully now you can list the factors of a number, and you can list the multiples of a number up to a certain limit.